What we consider to be modern statistics is a fascinating area of mathematics, and it is a somewhat recent addition to mathematical history and was, to some degree, motivated by the desire of individuals to beat one another at gambling. It came after the refinement of calculus done by Newton and Leibniz in the 1600s, and for some this is surprising, that modern statistics came after calculus, given how complex and difficult calculus seems to be. Probability theory, which is a central element of the modern framework of statistical science, started around the 1650s, mainly through Blaise Pascal and Pierre de Fermat, although some of the groundwork for this was done earlier in the 1500s by Girolamo Cardano. Now, it is true that statistical thinking or reasoning was present prior to this. However, it wasn't in its refined mathematical form that we tend to see today in our textbooks. So that being said, what is the goal of statistics? Simply put, it is to better understand the world around us through data. And here we can divide statistics into two branches, one of them being descriptive statistics, which is essentially about organizing and summarizing data, and the second branch goes by the name of inferential statistics. And its goal is to use sampled data to draw some conclusion about the population. Or in other words, the question that statistics is asking is how can we infer the properties of a population based on data from a finite sample while accounting for its uncertainty. This is a crucial element of this question because most of the times we don't have data for the whole population. Instead, we have access to a sample of data which is just a small slice of the whole thing we are trying to study. Imagine I want to estimate the proportion of times Trump invents economic statistics. I can't analyze every sentence or crazy tweet he's ever published or spoken, so I take a sample of speeches and interviews and tweets, and from that sample, I generalize to the population of all his public statements, with uncertainty of course. Now let me introduce you to a philosophical problem that is pertinent to the field of statistics, and it surrounds the idea of induction, something that a substantial part of statistics is built upon. Not everyone believes that the induction problem threatens in any way statistics, but I'll leave that to you. Essentially, induction consists in observing patterns in what we've seen and project them forward to what we haven't. For example, the sun has risen every day, so we expect and take for granted that it will rise again tomorrow. However, upon further examination, there seems to be some discomfort in us taking this for granted. Known as the induction problem, this gave the philosopher David Hume some headaches. In a treatise of human nature published in 1739, Hume asked some simple but tricky questions. On what grounds do we justify beliefs about the unobserved based on past observations? What is the foundation of this inference? What is the process of argumentation that makes it rational? The problem is that any justification to justify induction seems circular. Induction is reliable because induction has been reliable. Or put differently, I believe the sun will rise tomorrow because it has always risen. However, why does the sun, having risen every day until now, assure us so much that it will again? Well, because it has risen until now? See? The problem is, we have gone circular again. So, when we are talking about statistics, most of the times the assumption is something like, this method would capture the true value 95% of the time, as long as the world keeps behaving in the exact same way. But why should we assume that? On the other hand, we have Bayesian statistics formulating the question to, given uncertainty, how should beliefs change? Essentially, a Bayesian conclusion is always conditional. Yet, Hume's conclusion still stands. There is no non-circular, purely rational proof that induction is reliable. And yet, it seems to work. Not everything meaningful rests on certainty. In fact, most things rest on what has worked well enough before, often enough. So, is this a problem? Please write down in the comments what you think about this.